In this video, we'll prove something nice about orthogonal sets. So I'm going to start with any inner product space, and I'm going to take a subset of it, which is orthogonal, so meaning that the different VI's are perpendicular, and none of them are zero. Then S is linearly independent. Alright, so this is nice because it means that there'll be bases for their spans, and so we'll talk a lot about bases that are orthogonal or orthogonal. It's going to come from this. Alright, so I'm going to start with a linear combination of the VI's that give me 0, and I want to prove that all the coefficients need to be 0 as well. So assume that A1 V1 plus A2 V2 plus AI VI plus AK VK equal the zero factor of V. Alright, so our goal, we want to prove that A1 equals A2 equals AK equals 0. So what I'll do is I'll assume that one of these isn't 0. That's why I put AI here. So assume AI is not 0. And I'll get a proof by contradiction. In fact, I probably don't need this, so let's remove it. That's how I think about it in my head, but I don't think I need the hypothesis. I'll prove directly that AI is 0. Alright, so let's take this equation. And I'm going to take its inner product with VI. This is the zero factor, so that's the same thing as VI 0 V. And you'll prove in class that this is actually going to give you 0 using the properties of dot product. In fact, you probably have done it already. Alright, so VI times this is 0, but that's also expanded. VI dot A1 V1 plus AI VI plus AK VK. We have an inner product. That means it splits over some and the constants come out. So this is VI A1 V1 VI AI VI VI AK VK. Perfect. Now I can take the constants out, so I get A1 VI V1 AI VI VI AK VI VK. Since it's an orthogonal set, all of these are zeros, except for this one. So here I'm getting AI times the length of VI squared. Remember that VI wasn't 0, and so at this point I get AI times VI equals 0. So I found two different ways of computing this inner product. One gave me 0, one gave me AI VI, so that gives you 0. But the length of VI is not 0 since VI isn't the 0 factor. But that was property 4. The only way of getting VV equals 0, that's if V was the 0 factor. And so here I end up with AI equals 0. And so I was right, I don't actually need to assume and get a product contradiction. I can use this to directly prove that AI was 0 by taking a dot product.